It's my pleasure to introduce our speaker, Professor Nina Kraus, who will talk to us about Of Sound Mind, how our brain constructs a meaningful sonic world. Nina Kraus, Ph.D., is a professor of neurobiology and otolaryngology at Northwestern University. She's a scientist, an inventor, and an amateur musician who has quite a collection of instruments in her home to play with. She uses hearing as a window into brain health. You have a short bio of her in our order of service. So I would just like to share Renee Fleming's endorsement of her book. Nina Kraus is a brilliant communicator in her explorations of music and the brain. Of Sound Mind is an engaging and entertaining read with lively analogies and diagrams. The book is accessible to those just getting their ears wet, but has much to offer for musicians and researchers as well. That's quite a recommendation from Renee. We welcome Dr. Nina Kraus, and Nina, I'm going to turn it over to you now.
Well, hello everyone. Good morning. I'm very, very glad to be speaking with you. And I want to make sure, is the captioning working? Good. Because I turned something off. I wanted to make sure I didn't goof. So, I think we all noticed that you started the service with sound of all kinds. And I think one of the big messages of my book and really about sound is that sound connects us. And sound is an enormous force in our lives that is right around us, but it's largely unrecognized. And I wrote this book so that we could honor sound and think about ways that we can better connect ourselves with each other. I think I would like to tell you a little bit about myself and the science about the book. I'm going to share my screen, which I think everybody thinks, oh, God, share my screen. But I'm not going to do that for that long. I mostly am very interested in dialogue and in communication with you, and I really welcome your questions. But let me go ahead and share my screen and just give you a little bit of background. So do you have my screen shared?
No, I just have.
It says you are screen sharing. You don't have it?
Looks good. No, we could see your desktop.
Okay, good. All right. Well, now I need to find a Unitarian North Shore. And get you guys somewhere so I can. Okay. All right. So this beautiful picture is this was what I was hoping would be the cover of my book, because it really reflects some of the beauty and the mysticism of sound and sound in our lives. But MIT Press they wanted the clip art, so we went with the clip art. But this picture was also drawn by the artist who drew, I have a partnership with a wonderful artist. Her name is Katie Shelley. And there are 80 illustrations in my book. And part of that is to celebrate the art in science. So if you go to my website, which is called Brain Volts, it's very easy to find, you will see that we study many things: bilingualism, concussion, music, reading, listening and noise, aging, neuroeducation, autism. And you might wonder, what are they doing at Brain Volts? Well, it all fits under the umbrella of sound and the brain. And so, this is just one way of convincing you that sound is huge. Sound is an enormous part of the things we care about. So I wrote this book, and I also, as when you read the book, which I hope you will do, you will find that science. One of my messages is that science is a deeply human endeavor, and it is made, it is performed by humans. And so here's me as a little human, and my mama is next to me. And I grew up in a house where more than one language was spoken. My first language is Italian. And my mom was a pianist, and I grew up playing underneath the piano while she played. And I think I must have learned at an early age that sound was important. And eventually, when I went to graduate school and I started studying biology because I love biology, I did an experiment where I was recording from individual cells, individual neurons in the rabbit auditory cortex, and we played a sound, and the cell, the neuron, responded. But then we taught the rabbit that the sound had meaning. And if you look, this is the same rabbit, same sound, same cell, but now the neuron responds differently. And this made a big impression on me. Our brain really changes based on what we do. And so again, a big message of my book is that we are what we do. Sound changes us. We are what we do. And so it is very important that we make the best choices and decisions for how we live our lives. So the first part of the book is about how sound works. And it is really the story of signals outside the head. So sound, signals inside the head, which is how the neurons connect and fire when sounds occur. And then I talk about learning, and that's, connecting the sounds with the electric activity that happens in the brain. And I love to hear this story about sound and the brain. I'm like a child who wants the same book read over and over and over and over again, because I love the story. I have told it, I have taught it, I have listened to it, I have read it, and I still want to hear it again and again. But if there's a little too much detail in that first part of the book, just skip over the detail. You can come back to it. I want to make sure that you get to the second part of the book, which is our sonic selves, and that's most of the book. But initially, what I want to get across is the fact that the hearing brain is vast. When we think of hearing, most people just think of the ear, and they don't think of the fact that we have connections that are connecting our ear to the brain, but more important, there are connections that feed our ear with information from how we think, how we move, our other senses, and how we feel. Now how I want to just show you a little example here. Maybe it's try to listen to a sentence. Did anybody understand that? Okay, now here is the sentence.
The juice of lemons makes fine punch.
Okay, now listen to the first one again. Do you believe me that what we know about sound really influences how we hear it? So this is very, very important. So, the fancy way of saying it is that our hearing brain engages our cognitive, sensory, motor, and reward networks. And we know this biologically. What do I even mean? By reward, it's how we feel, right? We know that sound engages how we feel, how we think, what we know, attention, memory. We put information together from our other senses when we are listening to sound, and motor is how we move. because sound is movement. Now, sound consists of many ingredients. You know, one of the reasons that we fail to recognize the importance of sound is because it's invisible. And a visual object has a texture and size and shape and color. It has ingredients, and you can see them plain as day. Well, sound, first of all, is just invisible, so you don't even know it's there. And then it has also many, many ingredients like pitch, timing, timbre, harmonics, loudness, phase, many, many ingredients. And our brain needs to make sense of that. So we take these sound ingredients, feed them into our brain. And an analogy I like to use is that we can think of our brain as a mixing board. And we have different faders on the mixing board that go up and down based on our life in sound. If you spend a lot of time playing music, or if you speak another language, or if you have linguistic deprivation, these different phasers will go up and down based on your life in sound. And we can actually measure this biologically. And we can measure it by, as I'm talking to you now, the neurons in your brain that respond to sound are producing electricity. And by putting sensors, by putting scalp electrodes on your head, we can measure that electricity. So we can see how good a job your brain does at processing the different ingredients that are in the sound wave and in the brain wave. And you can see that the sound wave and the brain wave actually look very similar. So we can listen to the brain's response. How do we do that? Well, you're listening to me now. I'm talking through a microphone, right? And the reason that you can hear me is because the sound is transduced from this electrical signal into sound, and you hear it through the speaker of your computer. Now, if I was measuring your brain's response to sound right now, I would measure electricity. And then I can make that go through your speaker too, because any electrical signal I can sonify. So there you go. I want to give you some examples. Here is the sound wave, and here is here's the brain wave. So, we have a lot to work with here. But importantly, all of us hear sound differently based on our lives in sound. And so if you take something like a little snippet of A Hard Day's Night, so this is just played by a keyboard. Here are 3 healthy brains, and you're just going to hear how differently each brain how each brain processes this Hard Day's Night. And it's all recognizable as A Hard Day's Night, but there are profound differences. This is brain 1. Brain 2. Brain 3. So I want you to understand that we each have our own sonic fingerprint. Here are the responses to a speech sound from 6 different people. And if I measure your brain response to a speech sound, say these white waves now, and then I measure them tomorrow, they're going to look the same. Here's the same person recorded at another time. You can see that we all have our own neural signatures. And so this is important. We are what we do, which again is important for the choices that we make in our society, for ourselves, for our children. We know that making sense of sound is one of the hardest jobs that we ask our brain to do, which is why if you get hit in the head, you will disrupt that sound processing. And we have a big study that is funded by the National Institutes of Health at Northwestern University, where we measure the brain activity to sound in all of our 500 Big Ten athletes. And We measure them at the beginning of the season and at the end of the season. And if an athlete sustains a concussion, we can measure it again. So here is a healthy brain. And here is a brain that has sustained a concussion. So I want to play this little clip for you. This was actually Renee Fleming was part of this series as well. But let me, I hope you'll enjoy this little piece.
So finally, we have science meets art. Here is the brain keyboard. And we have recorded the brain's response to every note on the keyboard. Can you play a couple notes for us? So this is the brain's response to individual notes. And now you will hear Mark Meadows play the brain. Thank you.
So this was a little performance at the Kennedy Center. Okay, so now this is the real meat of my book, which is how our life in sound shapes our brain. And if you look at our sonic selves, there are chapters, there are individual chapters on music, because remember I said that that the hearing brain engages how we think, feel, move, and how we combine information from our other senses. Well, music really does that. So it's the jackpot. I have a chapter on rhythm. The root of language is sound. And remember, we were speaking to each other for hundreds of thousands of years before writing came on the scene. Writing just happened in the last 5,000 years. So our brain is really evolved and is primed for sound in a deep, 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 deep way that we are forgetting. Music and language have a partnership. What happens if you speak another language? I have a chapter on bird song, a chapter on noise, aging, and sound and brain health. This is our work on athletes and concussion. And finally, this last chapter is my call to action. It's really asking the reader to think about their lives in sound and what we can do to strengthen our society from a sonic standpoint. So music, I said, was the jackpot. Just a couple things about music. We've done many, many, many studies on thousands of musicians recording their brain responses to sound. But importantly, there are certain aspects. Remember, I said that there were certain sound ingredients that are just part of sound. And making music, and by making music, I'm referring to me as a musician. Anybody who just regularly plays music. You don't have to be any good, but you're just regularly, you might play a couple times a week in a regular fashion. And certain parts of sound are enhanced, the timing, the FM sweeps, there are particular parts, the harmonics of sound, which are so important because they help us not only distinguish two instruments playing the same note, the instruments sound different because of their harmonics, but the harmonics also help us distinguish a G from a B. So these harmonics are very important. And if you play a musical instrument across the lifespan, and singing counts, these ingredients are strengthened. Interestingly, and very importantly, these three ingredients that are strengthened by music are the ones that we most need for language. And we find that children who have language impairments have problems in the processing, their brain's processing of some of these ingredients. We know from an emotional standpoint that we can understand a baby crying from the harmonics, and we know that musicians are better at the musicians here in red are better at understanding, does the baby mean it? You know, when you hear your baby crying in the night, you need to decide, am I going to get up, or is it going to be better for me and my baby if we just forget that he's crying and try both of us to calm down and fall asleep? So musicians are better at picking out the emotion in sound because of their strengthened harmonics. What happens as we get older? There are ways throughout our lives to strengthen sound processing in the brain: speaking another language, playing music, assistive listening devices. As we get older, what often happens is that some of these the processing of some of these ingredients gets worse. But if you look at an older musician, the faders on this mixing board of the older musician, this older musician brain looks indistinguishable from the younger person. So really what we do really makes us us. And music is a lifelong endeavor, in that if you play at some time in your life, I'm sure many of you have played maybe when you were in high school, and even if you haven't played for 40 years, your brain will still be different from someone who has never had that music instruction. Speaking another language is a way of strengthening the brain's response to sound. Again, we often see cognitive decline with aging, but not so much with the bilinguals. We have looked at kids in underserved areas in Chicago public schools and in Los Angeles, and have found that music education can really strengthen their responses to sound. Here are some of our wonderful kids getting their brain waves tested. And what we have learned is that a signature of poverty, if you are brought up with linguistic deprivation, if you are not spoken to a lot, and if you don't engage with other people, what happens is you have a very noisy response to sound. And on the other hand, if you have been linguistically enriched, then you have a response that is very clear with respect to what the sound is, and the background noise is also much cleaner, much less. So one's ability to make sense of sound is better. So we have this linguistic signature of poverty with this decrease in these important sound ingredients, and we wondered whether music could help offset that. And it didn't change the background, the neural noise in the brain, that stayed high in the kids. But what we did see is that these particular ingredients, these sound ingredients, were processed more strongly in the kids who had music lessons. It takes time to shape the brain, so this is an investment in time. And finally, concussion does disrupt the hearing brain. And here are some of our adorable athletes getting their brain waves tested. And we were wondering whether, since we measure these brain responses at the beginning, at the end of every season, we wondered if being physically fit changed one's response to sound. And so we looked at 500 just Northwestern students and compared them to our 500 Big Ten elite athletes. And we wondered whether these important ingredients would be enhanced in the athletes, and they weren't. They were not. But what we did find is that the neural noise, our brain is always on and there's always electricity going on. Think of it as static on your radio. There's all this static going on in your brain. And what we found was that the elite athletes had quieter brains. So even though these ingredients were not processed more strongly, in effect, they were, because if you have a quieter brain, you're going to be able to make sense of everything around you better. So if you compare, for example, a typical person, so here is their response to sound, and here is the background noise. If you look at the athlete, the response to sound is the same, but the noise is less. So you can see the response better. And if you look at a bilingual or a musician, the noise isn't affected, but the signal, the brain response to sound, is strengthened. So it's really interesting how, based on the different things that we do, we can strengthen sound processing in the brain in using different mechanisms. So my final point to you is that sound connects us. And really, sound is one of the ways in which it's so alive, because as I hope we will have a discussion and we'll go back and forth. And we don't have a script. We just respond to each other. And that is just a fabulous thing about sound. And one of the best examples in my mind for sound connecting us is when you sing harmony with someone else. If anyone has ever done that, that it's this back and forth and back and forth. You're listening to what they're singing, and then you're changing your own voice, and then they are changing their voice based on what they're hearing, and it's just this back and forth connecting us. So this is my final slide, which is again our website, and I encourage you to visit that and to take. There's a little bus on the homepage that is a tour bus. So I encourage you to take that tour and find something that you might be interested in knowing.